My name is Guru Singh. I'm the founder and CEO of Scispot. We provide data infrastructure to life science labs, and our goal is to really make these labs AI ready. I didn't want to make a commercial talk, so what I did is, based on all the knowledge, all the institutional knowledge we have gathered by working with other labs, on how do you make your lab, your business AI ready. I want to share some of the intro level things. So when you are planning to make your labs AI ready, what are those 6 things you want to keep in mind? So that was my goal of the talk. And because it's only 15 minutes, I'm going to focus on LLM, not necessarily machine learning based AI model. But before I do, I want to draw a comparison with what happened in early 20th century. Just like right now, we have this AI revolution. We have a lot of pre-trained model. We have this ChatGPT. Everyone is using ChatGPT for everything. In 1920s, 1910s, most factories were talking about electricity, exactly how we are talking about integrating AI. They were talking about how they can integrate electricity and replace all of their steamers, all of their boilers, and really run their factories in a more scalable way. But to really integrate electricity, they had to do a lot of structural change. They had to rewire their factories. Today, labs, to be ready for AI, they have to do a lot of restructuring, a lot of rewiring to be able to integrate AI, in this case, LLM. And I'm going to talk about what are those rewiring, restructuring to be able to integrate LLM. There are 6 things. We all know what are those things, but I'm going to go a little bit deeper. One is you want to digitize your data. Currently, most labs have data in the spreadsheet. So that's not enough, but that's step number 1. Number 2 is you want to standardize your data model. Number 3 is you want to automate your data pipeline. In labs, we generate data from instruments. We have observational data. So you want to figure out a way to automate how we capture data and then ingest that data into our standardized data model. Number 4 is you want to harmonize and engineer features. Engineer feature is a technical term. I will talk about it, like how you can make the data a little bit richer for AI. So not just raw data, but a little bit processed data. Then how can you plug LLMs into your context? Because I heard in the last talk, we were talking about how AI is so unreliable. I'm paraphrasing. It hallucinates, it makes up things. And there's a reason why it makes up things. But there are ways to reduce that hallucination. So I'm going to talk about that. Then measure, govern, and iterate, because no matter what you do, there will always be some gaps. You want to monitor that by setting up your KPIs, like what's your tolerance in terms of accuracy, and then keep making changes either through context engineering or fine-tuning. There are different ways how you can improve the accuracy of these models. This is simple. Digitize your lab. We all understand that. But even when we digitize, we want to make sure there's some system in place. Because when you digitize, your goal is not just to bring things in your laptop. Your goal is to make the data machine readable. And to make things machine readable, you need proper ID structure. You need proper traceability, the auditability of your data. So you know when machine understands, are you talking about batches? Are you talking about runs? Are you talking about material lot? Are you talking about upstream data, downstream data, or analytical data? So digitization, we all understand, but digitization, thinking about machines as final beneficiary, not just humans. Currently, when we digitize, we think more about digitizing for humans, but digitizing for machines. There are different ways. I'm not going to talk about the product too much that you can achieve. Second step is digitization with some thoughtfulness is important. Second step is you need to standardize your data model. Data model is more like a digital brain of your manufacturing sites, your labs, your business. In case of bioproduction, bioprocessing, data model can mean your cell line data, your strain data, your analytical data like HPLC, your bioreactor data, all the results you are generating, your experiment metadata. So you want to digitize them in standard databases. You want to set up these standardized databases and connect them so your machine understands what is the relation between different data sets. And the goal here is to really replace these hundreds, thousands of spreadsheets that labs generate after every run. Okay, so step number 2 is done. To understand the digital maturity of this group, if you work in a production site, like what is the current state? Do you still have data on paper, or is it all spreadsheets or LLMs? Like how many of you have data models standardized? I want to make sure I don't go too basic. If you raise your hand, is it like data model standardized? Somewhat. That's a good start. So you want to standardize your data model, and it sounds very trivial, but it's like a must-have when you set up the foundation for AI. Okay, so we have proper digital brain. We understand where you want to capture historical knowledge, historical data. What you want to do is you want to automate data pipeline. In simple words, all it means is all of your data sources like instruments, bioreactors, you are automatically capturing that data. Not just, you're not receiving some CSV file or some random data point, you're cleaning it up, creating spreadsheet. You don't want to leave any scope for human error. So automating data pipeline by bringing data, transforming it, ingesting it into tabular format, calculating values that are important to you, like what is the signal to noise ratio. So you want to calculate as much as possible, so data quality is richer. I'm showing you these screenshots, GIFs from Scispot platform, because these are the things we automate. Alrighty, we are very close before we talk about how you leverage LLM, how do you integrate it. So you want to harmonize and engineer features. What I mean by that is you need consistent ID format. We need to normalize units. We need proper naming convention. You cannot use 10 different names for one thing. So you want to do that cleanup, final cleanup, for AI can even touch it and really extract the real value out of it. You want to do feature engineering, which is technical term for making data more like a richer for AI. Like if you compare seeds and oil of seeds, so you basically calculate few things. So when you give that data, when AI processes it, it's slightly richer. So feature engineering is very important. You want to calculate all the signal to noise ratio and other values in advance. Alrighty, so your data is ready. You harmonize it by using either Python scripts or your LLM prompts. Now you want to integrate pre-trained model into your data. How do you do it? How do you connect LLMs with lab knowledge? So when I say LLM, I'm talking about pre-trained model by Google, Azure, OpenAI. They have these models trained with everything on the internet, right? They chunk that data and build these models. These models are nothing but they operate more like predictive text engine. So when you ask something, it predicts next set of words. It doesn't necessarily have memory. It has no memory. It is just doing the guesswork. That's why it hallucinates. So your goal is you want to contextualize it with your own data. You want to build some memory, or at least guide the response. So it's not random set of, it works in a magical way, it still works, but you still want to contextualize it, really guide the response with your reference data. How do you do it? There are 4 different ways how you can use pre-trained model in your context. One is RAG, like retrieval augmented generation. It basically means you use all of your data stored across different places. You store that data in vector database. In simple words, vector database is nothing. It basically, you can upload all of your files, including unstructured data. It doesn't have to be tabular. It creates chunks of your data and store it in that vector. So you create the reference database connected with pre-trained model. I'm going to talk more about it. Second is you build your own graph database, your own ontology, which is, it's not like a linear 2-dimensional, but it's like a 3-dimensional knowledge graph you build with your institutional knowledge and then connected with pre-trained model. You can also build like a loop. So every time you ask a question, there's a response. It will enrich your knowledge graph. So that's many labs are working on. Third is, that's more permanent and more static, is fine-tuning model. Meaning you actually give training data sets and make changes to the model. First 2 approaches, they don't require any changes to pre-trained model, but in fine-tuning, you're actually feeding the training data sets. It's slightly expensive, and you have to keep doing this with updated data. Third is more agentic workflows, more like compound LLMs. You can combine LLMs and automate your workflows. Now let's go one step deeper. So how does RAG work? When you ask a question to your ChatGPT, it gives you a response based on the pre-trained model, right? But this pre-trained model is trained with not just scientific, it is trained with scientific data too, because anything that's in the public domain is trained, but it doesn't have memory, specific memory to any one thing. So how RAG works is, in simple words, when you ask a question, it first sends that query to your reference database, which is a vector database. It contextualizes your query and then sends it back to pre-trained model and then gives you a response that understands your context. It doesn't make any changes to pre-trained model like GPT. Your model stays the same. All it does it, every time you ask something, it sends it to subject matter expert of your lab, meaning your reference database, contextualizes it, then give it to pre-trained model again. And your response is much more specific, much more contextual. That's RAG. Here's some example. Let's say if you set up your vector database with all of your batch record. So if you ask GPT about, let's say, exact buffer recipe for your harvest clarification, some step in some specific batch, GPT will use that query, send it to your reference database, contextualizes it, and then send it to pre-trained model, and your response will be very specific. That's basically, it will learn from your historical data. There's another approach to reduce the hallucination. That's more graph database, like more building your own ontology. That's slightly complicated. It does require some human involvement to clean up the data, to label the data. You can use AI to do the labeling too, but generally it does require some subject matter expert do the cleanup a little bit. So your graph database, this is not vector database, but this data has more connections, more associations. So when you ask something complex to your pre-trained model, it will send it to your reference database. It will give the result back. And again, that contextual response will go back to pre-trained model. And then you will have the final answer. But not just that, you can set up a loop, meaning as you are expanding your institutional knowledge, you want to keep updating your knowledge graph. Number 3 is fine-tuning. How labs do it is they set up questions and answers, like answers to questions we already know, to tell AI, when I ask this, I would expect response like this. Otherwise, if you ask something to ChatGPT about your protocol or your SOP, AI will not say, I don't know. It will come up with something. It has like a people pleaser problem. So you want to reduce that. So you want to give set of questions and answers and then really train the model, fine tune the LLM. And it also matches your consistency, your tone. If you give 1,000 questions and answers, it will also try to match your tone. So when you ask something to ChatGPT, response comes back because the way they responded, it's because it's trained with that style, with that tone. Fine-tuning it does require update because your data, as you scale your lab, it keeps updating the data, keep growing the data. So meaning you have to keep updating the pre-trained model. So it's not like you do it once and you're all set, right? But if you compare it with RAG, your reference data keeps updating and it's always connected with your model. So you don't have to necessarily update it just to get the more contextual response. Fourth approach, which is the most popular one, labs are using it these days. You combine different AI agents to perform different tasks. For example, you can say, when I receive data from my fermenter, analyze it, find all the discrepancies, create a report, and send the email. So how I will design this? You can use tools like n8n, more like advanced version of how we use Zapier, right? All you do is you have different LLM agents in between. In this example, you bring the data from your bioreactor, you analyze it, find discrepancies, right? So you can design one AI agent how to find discrepancies. Once you find the discrepancy, let's say your next task is, so you're combining multiple tasks and automating it. So that's how people connect with the LLM. Second task is to create a report. So second LLM agent will be trained how to create a report with a prompt. Third will be send an email. So you can connect it with your Gmail or Outlook. right? So it combines set of integrations with few commands, few prompts. Most companies are using it even for other purposes like blog writing or proper review process to monitor discrepancy. There are some of the examples, right? So how companies are using it, they connect it with their LLMs, ELN instruments and set up their own rules. It's a great way to automate some of the things you do on a day-to-day basis. That's pretty much it. Any questions, comments?
We'll take a question back here. Hi, could you touch a bit more on the data standardization aspect of it? Because for us, we have various projects, and the data inherently, I don't think it can be the way it is. The projects are. I don't think inherently it can be standardized per se. It's pretty fluid. So in that sense, how do we go about it?
Can you talk a little bit about your lab? Like when you say there are multiple things involved, is it like mass spec, bioreactor?
Yes, it would be bioreactors. We work with different cell lines. We work with different GOIs, if you will. So a lot of variables right there.
So you generally set up these data models specific to workflows. So if it is more bioprocessing or analytical, generally companies set up databases specific to their workflows. It's not necessarily company-wide, and then find the connection between across different workflows. And it's not a easy exercise. Like we have some customers, I don't think I can name them, but there's one customer that uses our platform to standardize data they receive from CROs in different domains. So what we did with them is we set up their data model for different type of work, like they do binding assays or in vivo work, even clinical site, a clinical trial. So they have separate data models. There is some connection across different databases. And then you do a lot of troubleshooting. It's not like you set it up once and it stays the same, and you find issues and then you tweak it. You have to evolve it over time.
So we are a relatively small company. For us, we have not implemented any AI yet.
Yeah.
And one question is, if we have to start, where do we actually begin to start to implement it?
I think the first step will be to create like a clear registration system. So you need ID structure for your experiments, your runs, your inventory, your sample, right? So that's the only way you can make things machine readable. You need a unique ID system. If you work with a lot of samples, you need proper barcoding and process in place so you can scan those samples. So there's some identification, right? You cannot have, for example, a spreadsheet for every run and then data is lost. And it's really painful to scale with that process in place. So you want to create clear identification system. Then you talk about set up the data model, standardize it, set a few automation. So I would say start small.